Hi guys, so this is Rakesh Silreja, and now in this GENCO 2024 paper discussion, I will continue with the subjects of signals, communication and microprocessor. Of course, there is only one question, that is a direct question from microprocessor coming up. Communication also has given just one or two questions for you. Signals has given around 5 to 6 questions. Okay, so let's also talk about the difficulty level one by one. So this is the only one question from microprocessor coming up from 8086. Okay, so 8085 also they ask normally 8086, but a very factual, not a programming question. Okay, what is the maximum length, okay, of the machine language instruction for 8086 microprocessor? And you should know that it is 6 bytes. Okay, if it is a 8085 environment, the highest instruction size is 3 byte. Okay, but in 8086 the highest instruction size is 6 bytes. So almost a factual question, and only one question from the microprocessor. Okay, so if you have studied, you know it. That's a simple thing I'll tell here. Okay, now a question from sampling. Okay, signal and system. The signal xt is equal to 3 cos square 250 pi t, and that to one of the very common signal, like whenever you get questions on sinusoids or sampling function, okay, you can directly comment on the answer, because okay, if it is only cos omega naught t, okay, if it is only cos omega naught t, what is the highest frequency component is omega naught. Okay, because we know that if you talk about the Fourier transform of cosine, it contains only two impulses located at the fundamental frequency of the signal. Okay, only the impulses located at the fundamental frequency of the signal, that is the omega naught and minus omega naught. Okay, the Fourier transform, okay, for this signal x of omega, if you draw, it is given by, okay, 2 pi. This will have the coefficient or the area 2 pi del omega minus omega naught, one impulse at omega naught, another at minus omega naught, and the highest frequency component seen is definitely omega naught. Okay, now cos square, of course, now you can solve it by trigonometry also, or you can apply the simple law. See, if you take cos square, okay, okay, if you use the identity, cos square theta will be 1 plus cos 2 theta. Okay, 1 plus cos 2 theta divided by 2. Okay, and in this case, the highest frequency component will become 2 or 2 omega naught, or you can also apply the bandwidth rules. Okay, whenever two signals are multiplied, the bandwidth will be added. Okay, the highest frequency component will be added, so that also you can say it becomes 2 omega naught. Okay, so right now the highest frequency component is 2 omega naught, that is twice of 250 pi, and that is equal to the 500 pi. Okay, now this is sampled at regular intervals of t seconds. The maximum value of t, that means, okay, what is this t? Basically they are asking the sampling time period. Okay, the maximum value of the sampling time period, okay, for which xt may be recovered from the sampled version. Recovery is possible, okay, if you follow the Nyquist rate procedure, if you follow the Nyquist criteria to avoid aliasing. Okay, so recovery is possible if the sampling frequency is greater than equal to 2 omega m. Okay, and the minimum sampling frequency is what is known as the Nyquist rate. Okay, that is what is known as the Nyquist rate. Okay, okay, and according to it, what is the maximum time period? Because frequency and time period are inverse. If you talk about minimum frequency, time period is maximum, and that is given by 2 pi by, okay, 2 pi by omega. Okay, 2 pi by 2 omega m, and hence the answer should be pi by omega m. So my answer here is pi by omega m. The frequency here is 5. The highest frequency component, considering cos square, it is 500 pi. The answer is 1 upon 500. Now you see options are in milliseconds, so I divide. Okay, I divide and multiply by 1000. Okay, so into 1000. Okay, if you do, so 1000 by 2, and into 10 power minus 3 will be milliseconds. So correct answer is 2 milliseconds. The option number B is the very correct answer. Okay. The option number B is the very correct answer. Okay, dear. Okay, let's move ahead to the next question. Okay, a communication question. I'll discuss this communication also. A super heterodyne AM broadcast receiver, and it's a very direct question. And let me also tell you that this same question was there in the GENCO 2015. Okay, they have just copied this question directly. For signals, it is for the GENCO exam. Signals is of course for the first time. Communication was there. Okay, always they'll ask just 1, 2, 3 questions only. This is directly same repeated question of 2025 paper. A super heterodyne AM broadcast receiver has a IF of, okay, 455 kilohertz. Intermediate frequency is given. If it is tuned to a 700 kilohertz frequency, okay, the carrier frequency is given, intermediate frequency is given. What is the image frequency? Okay, what is the formula? Carrier frequency plus twice of the intermediate frequency. Direct one line formula question. Okay, and normally that is what is expected, for electrical guys. Communication questions they usually ask very straightforward. Okay, so plus twice of 455 kilohertz. Okay, so that is 700 plus 910. Okay, 1610 k, 1610 kilohertz. Option number A will be correct here. Okay, option number A, 1610 kilohertz will be the very correct answer. Let us go to the next question then. Okay, when the temperature, okay, in degree Kelvin of a resistor is doubled, the RMS value, okay, of the noise voltage. RMS depends on, if the RMS, value of the noise voltage depends on the under root of the temperature. Okay, this RMS value is proportional to under root of the temperature, and the temperature is doubled. Okay, this is what is proportional to under temperature. If the temperature is 2 times, so this should becomes under root 1 by 2 times, that is 1.414. Okay, 1.414. Okay, the actual formula, okay, that you also know. Okay, for the RMS noise voltage is basically given by 4 kTr into bandwidth, under root of 4 kTr into bandwidth. Okay, where K is the Boltzmann constant, T is the temperature, absolute temperature. Okay, and R is the resistance, BW stands for bandwidth here, right? Okay. Okay, so proportional to under root of temperature. So temperature doubled, the effect will be root 2 times, which is 1.414. Okay, let's go to the next question. This was also a direct question, very simple. Okay, the noise voltage across the resistor. Okay, signal and system. This is little calculative. This is time consuming. So normally, maybe in the exam time, because 100 questions, 100 minutes. Okay, just 1 minute per question. So normally students first attempt those questions which are straightforward, and that is what is suggested also for such examination. Okay, here convolution sum has to be taken. Okay, impulse response of a discrete time system is given to you, Hn. Okay, the input to the system is given to you, Xn. Okay, what is the output of the system? So how do you determine the output? Okay, the output is determined as the input Xn convolution with the impulse response. This is how we solve. And in the discrete domain, we have the convolution sum formula that is given by summation of xk h of n minus k. Okay, for k equal to minus infinite to plus infinite. Okay, now let me place down. Okay, let me start solving here. Okay, so what is the yn here is given by summation of xk. What is xk? Now xn is 2 power n u minus n minus 1. I will place as a function of k 2 power k u of minus k minus 1, h of n minus k. So place it as h of n minus k. You have u of n minus k minus 2. Okay, for summation k minus infinite to infinite. Now whenever unit step comes inside the summation, you should modify the limits. Okay, so minus k minus 1, the unit step will take one value 1 or 0. Okay, whenever it takes the value 0, the whole summation is 0. So that limit is not to be considered. Now, when does the unit step takes the value 1? When the argument is positive, greater than equal to 0. Minus k minus 1 greater than equal to 0. This tells you that k should be less than equal to minus 1. Similarly, from here, n minus k minus 2 should be greater than equal to 0, suggesting that k less than equal to n minus 2. Okay, so k less than 1 and k less than n minus 2. What should be k? K less than minus 1, k less than n minus 2. What should be the value of k? Now, it has to be smaller than the smaller number. Now, okay, n is time variable. Okay, that can be small also, that can be big also, because time is a variable. So what will I do here is there can be two cases, dear. Number 1, n minus 2 less than equal to minus 1. Okay, this suggests that n is less than equal to how much? 2 minus 1 is 1. Okay, now in that case, what you want? Okay, in that case, what you want? Okay, let me draw it here only. You want k less than minus 1 and k less than n minus 2. N minus 2 will be before minus 1. N minus 2 less than equal to minus 1. So you want k less than this also, less than this also. What is the common portion? Up to n minus 2. Up to the n minus 2. Okay, so here, dear, answer should be yn equal to summation k is minus infinity to infinity in general, but here k should be only up to n minus 2, less than n minus 2. So minus infinity up to maximum n minus 2. And then what is there inside the summation? Only 2 power k, because unit step value is 1. To make the value 1 only, we have taken this argument greater than equal to 0. Okay, so now place down the upper limit. Okay, I will go, see summation, whether you go from bottom to top or top to bottom, order does not matter in summation. So I will start with the top limit 2 power n minus 2. Okay, next will be 2 power n minus 1. Okay, we are going down. Sorry, n minus 3, we are going down. 2 power n minus 4 for infinite number of terms. Okay, up to 2 power minus infinity, which is 0, total infinite terms. Okay, so this is a GP with infinite number of terms. Okay, what is the first term of the GP? What is the first term of the GP? 2 power n minus 1, oh sorry, n minus 2 divided by 1 minus common ratio. What is common ratio? Every time, okay, 2 power minus 1 minus 1 minus 1 is coming, na? Because we are going down, the 2 power minus 1 minus 1 minus 1 is coming every time multiplied, okay? So common ratio is 2 power minus 1, that is 1 by 2. Okay, that is 1 by 2, and the common ratio mod r less than 1, that is why GP converges, otherwise the GP will not converge, we know. Okay, so 1 upon half will be 2, so twice of 2 power n minus 2, okay, that can be written as 2 power n minus 1. Okay, so the answer is 2 power n minus 1 for n less than equal to 1. Okay, now next case, before I go to next case, see 2 power n minus 1 expression has to come. Option number B or D. We can stop here for the MCQ question. Okay, but for n less than equal to 1, for n less than equal to 1, okay, now u minus n minus 1, okay, this starts from n equal to minus 1, u minus n plus 1 greater than equal to 0, okay, n less than equal to 1. This is the unit step function which will start from n equal to 1 or go below it. That's what I want. For n less than equal to 1, the answer should be 2 power n minus 1, correct? Right, so the answer has to be B. We can stop here for the MCQ question. Even if you have attempted this, you should stop here. Okay, but I will complete to give you the correct solution here. Okay, to give you the correct solution. Okay, right. So, you know, sometimes maybe 5-10% questions can be lengthy also, easy but calculative. Okay, but we have solved some similar models in our batches, in our regular batches, na? AE batches, we have solved similar model problems, exact similar model problem. Okay, so you should not be that worried. Now number 2, okay, now n minus 2 less than equal to minus 1. Next condition, n minus 2 greater than minus 1. Okay, that means n greater than 1. 2 minus 1 is 1. Okay, n greater than 1, now because it is discrete time, so greater than 1 means 2 or 3 or 4. So we can also call it as n greater than equal to 2. N greater than equal to 2. Okay, what is the output now? Dear, the output will be summation C. Now, this time again, if you take the number line minus 1 and the n minus 2 this time is greater than minus 1. You want one number here, you want the other number here. Okay, my k is minus infinity to minus 1, minus infinity to n minus 2. What is the common limit? This time, k should be up to minus 1, because if it is less than minus 1, automatically less than n minus 2. Smaller than the smaller number. Okay, so now yn summation minus infinity to plus infinity, but here I will stop at minus 1. K should be less than equal to minus 1, 2 power k. So start 2 power minus 1, go down. I am going till minus infinity. 2 power minus 2, 2 power minus 3. Again a GP is coming. First term 2 power minus 1. Common ratio is also 2 power minus 1, which is half. Okay, so mod r less than 1 is satisfied. 1 by 2 upon 1 minus 1 by 2. Okay, that is also half. Half upon half, 1. Okay, so how can I write down the answer, dear? The answer seems like yn, the first expression is 2 power n minus 1 for n less than equal to 1, and it is equal to 1 for n greater than equal to 2. Okay, and hence we can write it as 2 power n minus 1. Okay, the unit step which starts from 1, okay, your unit step which starts from 1 and goes to the left of 1, okay, is minus n plus 1. Okay, plus unit step which starts from 2, right shifted unit step. Normally unit step starts from origin. This starts from 2, the u of n minus 2. Option number B, as I already tick mark, that is a very correct answer. Okay, that is a very correct answer. Option number B. Okay, moving ahead to the next. So this was, yeah, little calculative. It required little effort. Okay, now this is again a simple one based on multiplication with impulse. What are the general properties you use? What is the value of integral minus 5 to 5? Some function xt is given. Xt delta double dash t minus 2. Okay, derivative of impulse is coming up here. Double derivative of impulse, where delta t is the impulse function. So dear, what we generally know, okay, integral minus infinite to infinite xt delta t or delta t minus t naught, okay, is given by x of t naught. Okay, minus infinite to infinite, or limits. See, limits can be minus 5 to 5 also. Only thing you have to worry is whatever is the impulse, that should be within the limits. If that is outside the limits of integral, then the answer is 0. Then the answer is straightforward 0. Okay, so yeah, let me call it as limit a to b. Okay, the answer will be x of t naught. Answer will be x of t naught. I will write down the common condition. Next result I will write integral a to b xt delta dash t minus t naught. Okay, the doublet function, derivative of impulse. This is given by minus x dash t naught. Okay, and the last integral a to b xt delta double dash t minus t naught. Okay, what is the pattern? This is now given by plus x double dash t naught. Okay, if you take xt delta triple dash with the third derivative of impulse, then you have minus, again a minus x triple dash t naught. Okay, so this is the pattern that usually moves. Okay, only thing is the impulse which is at t naught. The impulse is located at t naught. This should be within the limits of integral. This should be within the limits of integral. Otherwise, the answer is 0. Otherwise, the answer is 0, because if impulse is outside, it does not contribute to any area. Okay, so here, what is the answer then? Accordingly, here, what is the answer? This should be equal to, okay, this is the function xt I will call. This is the signal xt. Answer should be plus x double dash t naught. X double dash t naught. Okay, that is x double dash 2. Okay, the impulse is located at 2. Okay, and t equal to 2. Okay, is the t equal to 2 within the limits? Yes, minus 5 to 5, t equal to 2 is there. If it was outside the limit, then we say the answer is 0. Okay, so now what is the x dash? Okay, what is the x dash t first of all? We will go over the derivative. What is the first derivative? 3t square plus 12t plus 2. Okay, sine pi t derivative, pi cos pi t. Okay, then x double dash t. 3t square derivative 6t, 12t derivative 12, 2 is constant. Cos pi t derivative minus pi, so one more pi will come, minus pi square sine pi t. Okay, and then what is the value of x double dash 2? So 6 into 2 plus 12, and sine t equal to 2, the sine 2 pi is 0. The answer is 12 plus 12, 24. Okay, dear. Correct answer here is option number C, 24. Correct answer is option number C, 24. Let's go to the question number 30. Okay, the Laplace transform, it's a gate PYQ straight away, 2015 I think, yes, it's a straight gate PYQ. Okay, the Laplace transform of ft is 2 root over t by pi is s power minus 3 by 2. What is the Laplace transform of gt? 1 upon root pi t. Okay, so Laplace transform of ft is given to you, and then another signal. That means first if you relate gt and ft, then some Laplace property will come. Okay, then some Laplace property will come. Okay, so how can you relate? See, gt is 1 upon root pi t. You know what is the derivative of root x? Okay, or root t. Derivative of root t is given by 1 upon 2 root t. Okay, so if you take the derivative of this root t, look into this function. Okay, it becomes 1 by 2 root t. Okay, 1 by 2 root t. Okay, when you take the derivative of the function f dash t, okay, that is d by dt of 2 root over t upon pi, and that should be equal to 2 upon root pi. Now root t derivative 1 by 2 root t. Okay, so 2 cancel and you have 1 upon root pi t, and then you have 1 upon root pi t. Okay, 1 upon root pi t is the given function gt. Is the given function gt. So gt is related as the derivative of ft. Okay, derivative of ft. Okay, or there is one more relation. Okay, you can use any one of them. gt is also equal to ft upon t. Ft upon t. When you divide by t, root t by t will be root t upon t will be 1 upon root t. Here you get also divide by 2. Divide by 2. So anyone we can use. Okay, so let me use this. Let me use the derivative. It is actually more simple. The given function gt is the derivative of ft. So Laplace transform. Derivative f dash t, Laplace is given by s into fs minus f of 0. Okay, s into fs minus f of 0. Okay, now the Laplace transform of ft is given to you. Okay, s power minus 3 by 2. Okay, minus f0. Okay, so let's calculate that. See, this is what? This is the fs, Laplace transform of ft, and then I need f0 in the derivative property. If t equal to 0, f0 will be directly 0, na? Put down the value here. Okay. So s into s power minus 3 by 2, s power minus 1 by 2 is the answer. Okay, option number C is very correct here. S power minus 1 by 2, option number C is the very correct option. Okay, dear, let's be ready for the next question then. Here it is on your screen. Number 31. Okay, Z transform direct question. Okay, a Z transform direct question. This is of the form, okay, 5 if you separate, 1 upon 1 minus AZ inverse. Okay, 1 upon 1 minus AZ inverse. Okay, the Laplace, the inverse Z transform of this YZ function. Okay, now let's solve it. Okay, let's solve it. Whose Laplace, whose Z transform is 1 upon 1 minus AZ inverse? A power n un. has the Z transform 1 upon 1 minus A Z inverse, or also written as Z upon Z minus A. Okay, with the ROC, they have not spoken about ROC. That is why I have taken right-sided function. By default, we'll take causal. Okay, ROC mod Z greater than mod A. Otherwise, A power n, u minus n minus 1 will also have the similar Z transform. Okay, but there is no ROC given, means we of course by default assume the right-sided or the causal case. Okay, so what is the inverse Z transform then? Okay, what is the inverse Z transform? 5 into A power n un. What is A here in the given question? 0.2 power n un. Okay, so 5 into point, okay, they have called it as k function, no problem. Okay, so 5 into 0.2 power k. Now unit step, we can write it this way, na? 5 into 0.2 power n. 5 into 0.2 power n. Okay, unit step will only exist for n greater than equal to 0. Okay, otherwise the unit step will be 0. So correct, n greater than equal to 0, k greater than equal to 0, option number A. Okay, right? Simple formula, direct Z, and that too one of the very common formula of Z transform. Okay, not a random function also. The beginning functions that you study under the Z transform, A power n un. Okay, next one, number 32. Okay, and the last from signals. Okay, again a conceptual question from Fourier series. Which of the following statement related to Fourier series of 9 non-sinusoidal periodic signal, okay, with period t, ft is a naught, okay, the DC component, plus summation 1 to infinity an cos n omega naught t plus bn sin n omega naught t are correct. Okay, so normally this is what a trigonometric Fourier series contains. Okay, the DC component, the cosine terms and the sine terms. Okay, now it can be expressed in Fourier series if sampling conditions are satisfied and its amplitude spectrum is discrete C. Okay, it can be expressed in Fourier series if Dirichlet's condition are satisfied. Okay, so first statement is not valid here. Okay, now if ft is equal to minus f minus t with, okay, so the function is given to you as odd symmetric as well as rotational symmetric, which is also known as half wave symmetry. Okay, so if the function is odd symmetric, it will only contain, see, simple logic to remember is cosine is the even function, sine is the odd function, and DC component is considered as even. How do you draw DC? If I ask you draw a naught with respect to time, the constant is constant. Okay, so that means it is identical on the right and left. It is under even. You can call it as an even function. Okay, the simple logic to remember, if ft is an even function, okay, its Fourier series will only contain, okay, even terms, okay, like the DC and cosine. If it is an odd function, its Fourier series can only contain odd terms like sine. Okay, so first of all, given odd function, so only sine terms will be there, and whenever the function is half wave symmetric, only odd harmonics are there. Okay, so odd symmetry says that sine terms will come. Half wave symmetry says that only odd harmonics will come. And these are, very, very repeated and important property. Lot of stress I have given whenever I have taken that complete batch also. Very important. For AE also, GATE also, ESA also, everywhere. In Fourier series, the symmetry property, even, odd, half wave symmetry, all of these, okay, are very important property. Okay, so this will contain only odd sine terms. Yes, sine terms with odd harmonics. So statement 2 is correct. Out of the 4, we have then 4 options. Which of the statements are correct, we will see. Okay, if ft is f minus t now, okay, even, and ft is minus of ft plus minus t by 2. This is what actually half wave symmetry mathematically is. Okay, when you shift, okay, a signal by half the time period, right or left, anything, ft plus t minus 2 or ft minus t by 2, when you shift it by half the time period, and if it comes out to be minus of ft, then it is half wave symmetry. Okay, so it is again half wave symmetry. Okay, so half wave symmetry says that only odd terms will come, and even symmetry says that cosine and DC will come. But DC, A naught, is the even term. Okay, so in half wave symmetry, only odd harmonics and C naught will also be 0. If I only say even symmetry, cosine and DC will come. But even in half wave symmetry, the DC will not come. So only odd cosine terms, correct. Only odd cosine terms will come, correct. If it is, again I repeat, if it is only even symmetric, cosine and DC both will come. But because of half wave symmetric, only odd harmonics, no even term, and A naught, A2, all those, they are counted as even. Fine. Fourier series, next statement, Fourier series of an even function have a constant in cosine terms, correct, this is correct, and continuous amplitude spectrum, no. The Fourier spectrum, see, whether you talk about Fourier series coefficients or Fourier transform of a periodic signal, Fourier series coefficients Ck are discrete in nature, they are defined for integral values of k. Okay, ck, c0, c1, c2, c3. It is a discrete function. And even if you talk about Fourier spectrum of a periodic signal, okay, the Fourier transform of any periodic signal contains only impulses, okay, which are located at the fundamental frequency of the signal. Okay, so the amplitude spectrum is not continuous, it's actually a discrete nature. So statements which are correct is, okay, 2 and 3, option number D. 2 and 3 statements are correct, 1 and 4 are not correct here. Okay, yes. Okay, fine, dear. Thanks. So this is what, is the questions from signals. Also communication and microprocessor. Communication, very few questions were there. So that we have discussed, and majorly signals. We can call it, if you talk about the difficulty level, signals, it's not that easy also as per the AE level. Okay, because see, this question is thoughtful. Okay, property based, you should have studied the property, but reading statement one by one. Okay, and given the timing, just 1 minute per question. So accordingly, I'll call it as good question. Otherwise, it's almost something that students know, but it is, thoughtful. You have to read and analyze the statement. This one is very simple, direct. This is also property based, simple. It is actually a gate PYQ. Okay, this is also property based, integration with impulse, very common properties are there. This one is calculative. If you have solved this, takes little bit time. Okay, and this is direct question, the noise, the RMS noise across resistor, super heterogeneous receiver, direct question. Okay, and this is also sampling, easy question only. Okay, I'll not say very straightforward, but easy question. I'll put it as easy only. And this is a direct straightforward question of 8085. So some questions are straightforward, you don't have to do anything. Some are easy, little calculation, and some are thoughtful, like this Fourier series coefficient. Some are calculative also. So overall moderate level of signals, I'll call it as. Okay, so thank you, and keep enjoying the video with other subjects also to be continued by other faculties.